that said, there are several things we can do to improve the state of in the industry. And we've been doing a lot in this area. So interoperability. I believe you ought to be able to use a parallel programming method in part of your application and another one in another part, link it together, and it should just work. So all of our methods interoperate with each other. All the ones that I mentioned on the page before, you can use them, mix them, and match them. And this is incredibly important in a real program these days where you might take a library, you might have multiple modules, multiple groups work on an application. You just shouldn't have to worry about the entire application using the exact same method to get parallelism. OpenMP, the Intel and GCC's OpenMPs interoperate. Microsoft, the Intel and Microsoft OpenMPs interoperate, meaning if part of your application uses GNU's OpenMP and part uses Intel, or if you're on Windows and you're using Microsoft's OpenMP, these are implemented by the compilers. So if you compile some of your OpenMP code with Microsoft, some with Intel, and you link it together, it will work. We have a solution for that. We work very carefully with GCC and very carefully with Microsoft to produce a solution for that. And they weren't technically easy to do either. OpenMP is a specification at the for a language. It doesn't say anything about how to make it interoperate between compilers. But we think people should not have to worry about things like this. So, for instance, we may have a customer that compiles an entire application using OpenMP with our compiler on Linux, but they happen to include a library that was built with the GCC compiler that has an OpenMP code in it. That needs to work, in my opinion, so it does. Concurrency runtime, we work with Microsoft on its design. It was released in Visual Studio 2010 this last year. That is the heart of why Intel's task stealing algorithms and Microsoft's interoperate without issue. And we also donated some key code from threading building blocks to Microsoft to make sure that their locks and atomic operations that they decided to put in Visual Studio 2010 fully interoperate with our solutions. Again, because there's just no good reason why these don't just work together. So they do. So we've been very active in that. And of course, we're very active in every open standards committee that you can talk about, whether it's OpenMP, MPI, Fortran, C, C++, the OpenCL. We're involved in those, very committed to standards. I think this differentiates us from other tool vendors. I think it's important. I think others, there's a lot of interest in sometimes, if you can get away with it, creating proprietary extensions and keeping other people from using them. At Intel, we don't think that's the right way to go. We work very hard to work together for interoperability and so on. But leadership-wise, sometimes you have to produce something that nobody else produces and then see if you can't convince the industry to follow. So we've got Intel threading building blocks. We introduced this in 2006, so about 5 years ago, and it has become the most widely used abstract method for parallelism. And we're very proud of that. And it's very non-proprietary. This project's taken on quite a life of its own, which is great. And high degree of composability. So we're composable, we're self-composable, you can mix and match, you can nest this parallelism, you can do all the things with it that I think anyone today should expect of their programming language. It just works. So, we did introduce Threading Building Blocks 3.0 this last year. It's a very active project, growing. I said we introduced the first version of this in 2006, but every year there's new and exciting features, lots of customer feedback. Intel continues to be a very big supporter of this project and contributes a lot of the new code. We've got features in it for the new C++ standard that's almost completely approved. We've got support for Visual Studio's new release, some new documentation, all sorts of exciting new capabilities And there's some new features beyond 3.0 that are out there now, like TBB graph, to allow event-based processing and some other very interesting new features for threading building blocks. So threading building blocks has not stopped. And 5 years ago, that means we're in our 6th year now, and this has been doing quite well for us, quite well for everybody. So we've had a lot of adoption. Adobe's Creative Suite 5, I think I mentioned that earlier, shipped using threading building blocks. That means things like Photoshop and so forth have threading building blocks in them. Adobe is using threading building blocks now. Last year also DreamWorks Animation standardized on us. And we've got a lot of other companies that have been with us a long time doing things, and a lot more newer companies using us. So I can't do justice to listing all the companies that are using threading building blocks, but I can mention some of the big ones like that. And I think the fact that Adobe settled on using us is quite was quite exciting for us, because they had a lot of use of parallelism. They've been pioneers in trying to use it in different ways, but threading building blocks gave them that degree of composability. It was a solution that they could use throughout their suite and find great performance. So, given how great threading building blocks was, you could say, well, why do anything else? Why would we do anything more than this? Well, some of the feedback we get on threading building blocks is it's a C++ solution. You can use it in C, sort of. It doesn't do anything specific for data parallelism, and it doesn't leverage the compiler. In Intel, we've got a boatload of compiler technology, so why don't we use that to help with the parallelism problem more? And so we created this parallel building blocks project with an eye towards doing something about these. And so the first thing we took a look at was, well, we want to add the threading building blocks but not create any conflicts with it. So we don't want to create a new competing model that for some reason doesn't operate with it. And we want to help appeal to C programmers. We want to help with data parallelism, and we want to be able to get the compiler to help. And that, and of course, allow for some future expansion. So the Cilk Plus project was born. We acquired Cilk Arts company and their people and their technology, and created this, and we released it. It's in our compilers as of last year. So it's in Parallel Studio starting in September. It's in Parallel Studio XE in November. The first step to getting a new standard out there is to actually implement it and make it available for people to use. So we did that. And then last November, we also, with Cilk Plus, we released the full specification for it. And that started an effort that I'm very involved with, which is trying to talk to other compiler vendors about their interest in implementing it as well. And then array building blocks is a very big project on data parallelism that we're working on. So, we've got parallelism for C and C++ in parallel building blocks, a lot of capabilities for productivity, support for task and data parallelism. We can take advantage of SIMD instructions like SSE and AVX, and take advantage of multi-core, many-core like Mike, all together, and they just all work together, no issues. And we'll be able to spread this across processors and operating systems. Now, the status in doing all of that, threading building blocks is fully there. Cilk Plus and array building blocks will take some time, but when we launched threading building blocks, we had the same thing. So. Now, if we look at standardization, I wanted to say a few things about our efforts to standardize and put it in some context. I was involved, along with other people at Intel, getting OpenMP adopted. OpenMP's first specification was published in 1996. Intel and about 7 or 8 other companies were involved. Cray, SGI, IBM, Sun, compact. I probably shouldn't have named them because I'll forget some of them, but a lot of great companies worked with us on this. HPC compilers adopted it pretty quickly, but it wasn't until 2007 that Microsoft and GCC supported OpenMP. Nowadays, people can recommend OpenMP. It's very portable. Mixing binaries can be a bit of an issue, but if you're working on Intel platforms, we have solutions for that. There aren't any other platforms I know of that have solutions. For instance, if you use the GCC compiler and mix it with the Solaris compiler from Sun, OpenMP, they won't work together. I know that's an issue for them, and I don't. But if you're on an Intel platform mixing Intel, GCC, Microsoft, we have a solution for that. So we've got some compatibility. So this is a success. I'd say OpenMP, we were very successful at driving a standard that's now regarded in the industry as a reliable thing to program in and get results in. So we've got that. We'll continue to support that, continue to work on possible evolutions on OpenMP with the standards committee. Be careful on the steps. So MPI, another thing. My earliest days working with message passing, there was no standard. But that standard's come, and we've helped pioneer a new area in MPI, which was to be able to produce single binaries that support multiple fabrics. In retrospect, looks pretty obvious. HP did the same thing, although HP's MPI has been sold off now to another company, and Microsoft does the same thing on Windows. So we, helped pioneers in this new area, and now MPI is much more deployable than it was even 5 years ago. Much more portable. So I'd say MPI is doing a great job of being a standard we can count on. But these things are not so composable or broadly deployable. They're not going to be the programming solutions for everyone in this new multi-core world. So we boldly came up with Intel threading building blocks in 2006, and it was this has been an interesting ride, but one that's been very rewarding because we got this right, and people have thanked us for it, and in the most important way possible by using it and helping give feedback on it. So open sourcing this in 2007 was a great step that we took to take a really high quality task stealing algorithm and make it available to be ported all over the world to many, many different platforms. So this is widely adopted, and I think this is joining the ranks of being a technology that companies view and programmers can view as something they can count on. It'll always be there, and it's everywhere. It's whatever platform you want to use, you can rely on using threading building blocks. So now we have Cilk Plus. We're going to do the same thing with this. It's a rather bold statement given that we just released it in 2010. But we are very serious of helping convince others to adopt this, and we're very flexible. The definition may evolve, may change some, depending on the feedback. We're not so stubborn that if someone else wants to see the spec changed a bit, we are open to that. We need to be. So we will. We've got Cilk Plus, and we're going to take a number of steps this year. We released the full specifications for it. We're working with other compiler vendors. We're going to propose some of this into standards committees. We're going to release some of the source code to this, to the key source codes that's needed to implement this, to try to ease adoption, let other compilers implement it more quickly. We obviously can't do all the work for it to go in other compilers, but we can make it a lot easier by releasing some of our key source codes, so that will speed that up. So we're working on this. So Cilk Plus is very exciting when you look at it for what it can do. It's very easy to learn, very intuitive, and it's a little bit more powerful because the compiler is helping you. So that's very powerful, but it's only in the Intel compilers. That's the but. For some people, I think that may be enough, but when we start seeing other compilers implement it, that'll be the real key. So Cilk Plus is, I hope, on its way to this as well. And then array building blocks is further behind. You have to keep things in the pipeline. But array building blocks is built on a research project from Intel called CT. RapidMind acquired technology, and we merged that stuff, have it out, and I can give you a little bit of an update. We've been in beta for a while. Customer feedback's very specific in two areas. One, it's very promising, and anytime a customer tells you something's promising, there's a but. They said, but the performance isn't where it needs to be. We're relying on technology that was a merger of a research project and a company, RapidMind. RapidMind had great experience, and the CT research project had some very visionary research, but the combination of performance is what I call fragile. I can show you fantastic benchmarks for array building blocks, and but I would have to be honest and tell you that they're carefully selected. The compiler, the array building blocks group is very knowledgeable of what benchmarks we wanted to show off, and they've tuned to them. And this happens with compiler technology sometimes if it's not done right. And array building blocks, the core of it was homegrown. So what's going to happen now is we're going to reinvest in this and rewrite the core of array building blocks later this year. And I think, we haven't decided, I think we'll leverage LLVM or some other compiler that's out there, and that'll give us some opportunities down the road to open up array building blocks and share it with the industry more. I'm excited about it because we're at a point now where we know what we need to do, and we need to take a deep breath and reinvest in some of it. This is a very ambitious project, and we're very committed to it, and we're going to take a little bit of time and rewrite the heart of the thing that's causing the fragile performance. And we think now we have a path to getting the performance that I could show you today with nice graphs, but to get rid of the fragile nature of it, which nobody wants. So fragile means you see this great algorithm that Intel showed you how to get it to work really fast, but you change it a little and suddenly the performance is terrible. That's the way array building blocks is right now. That's not the way our other products are. So I don't want, we don't want array building blocks to join the fold of products before it's ready. So this is a very exciting project for me, and a great team, and I think we've got our sights right where they need to go, and this is going to be important. This will be ready for Mike, and that's the most important thing for array building blocks. Is when Mike comes out next year, the product version, the one built on Mike's corner, array building blocks will be there, and it's going to be a very important addition to our product lineup. So these are all very composable, very compatible, very forward scaling, and we will have all these in time be able to port everywhere and stick around forever. That's what we're looking for with TBB. A little bit visionary. We've accomplished it with threading building blocks. We're going to deliver it on the others. So that is parallel building blocks in a nutshell. And this year, we're going to get more customer usage. There's this mysterious book I should be working on. We've got a lot of university and professional training in the works, and we'll be working with the industry to make things happen. So that's a little bit about parallel building blocks, where we're at and where we're going. I still remember standing on stage telling people about threading building blocks and having a lot of skeptics, and we've got plenty of skeptics with parallel building block now, but quite convinced that we can help move the industry forward in terms of models that will turn out to be really critical for the deployment of parallelism in broader and broader scale. And I think nothing will be more important than when we see the core count suddenly jump like they will when we introduce Mike. When we go from today, which is 2, 4, maybe 10 cores, to a single piece of silicon that's going to have more than 50 cores on it. And we have OEMs talking about putting 8 of these in a box together, so there'll be a lot of cores. We want to have programming model support there, and I think we're on the right track for that. And honest, Christian, I started late, so don't look at me like that. But I think, Christian, you're going to introduce our next speaker, and I'll be available at lunch and around to talk some more, but I think we'll just go with the introduction, because I know our next speaker is going to be very exciting.
Exactly.
All right, thank you.